At 5:47 a.m., the facility lights come on in a controlled sequence. Inside a climate-regulated building in the main interior, millions of gallons of recirculating water begin their morning cycle. This is Atlantic Sapphire's bluehouse, the largest land-based salmon farm operating in the United States. The bluehouse concept replaces ocean net pens with a fully enclosed recirculating aquaculture system, known as RAS. Water is filtered, oxygenated, and returned to the tanks in a continuous loop. There is no ocean, there is no weather dependency, there is only the system. The facility in Homestead, Florida serves as the primary production site. A second expansion phase in Maine continues to add capacity. Together, some of these installations represent a shift in how Atlantic salmon reaches American consumers. Without a single fishing vessel, without a single ocean voyage. Salmon enter the system as eggs. They are sourced from certified broodstock suppliers and arrive under strict biosecurity protocols. From the moment they enter the hatchery, choose every variable, temperature, salinity, pH, dissolved oxygen, is logged and managed. Hatchery water temperature is held within a fraction of a degree. Salmon eggs are sensitive to thermal shock. A deviation of 2 degrees can affect hatch rates by measurable percentages. The system corrects in real time. Olivin emerge from the eggs after several weeks, still attached to their yolk sacs. They are held in shallow trays until the yolk is absorbed. At that point, they begin feeding independently and are moved to first-stage rearing tanks. First-stage rearing tanks are smaller, carefully controlled, and stocked at precise densities. As fish grow, they are progressively transferred to larger tanks. Each transfer is a calculated operational event. Fish are crowded slightly to encourage movement, then sorted by size. Recirculating aquaculture systems work by removing waste from the water before returning it to the fish. Mechanical filters remove solids. Biological filters process ammonia. Ultraviolet sterilizers eliminate pathogens. And the result is water that can be reused indefinitely. The oxygen demand inside a salmon farm is continuous. Diffusers inject pure oxygen into each tank. If a diffuser fails, fish begin to surface within minutes. Redundancy is built into every oxygen delivery line. Backup systems are tested on scheduled intervals. Feed is delivered automatically through overhead auger systems. Pellet size scales with fish age. Nutritional formulas are calibrated to target growth rates without excessive fat accumulation. Feed conversion ratios are tracked daily. Every kilogram of feed is measured against every kilogram of fish gained. Water quality analysts work in rotating shifts. Every 4 hours, samples are pulled from multiple tank zones and tested for ammonia, nitrite, nitrate, carbon dioxide, and temperature. If any parameter falls outside tolerance, feed rates are adjusted or tank flow is increased. Salmonids grow through distinct life stages: egg, alevine, fry, par, and smolt. In the ocean, smoltification, the biological transition to saltwater tolerance, is triggered by changing day length. Inside a RAS facility, it is triggered by light manipulation. LED photoperiod systems mimic seasonal cues on demand. Smolts are the juvenile stage ready for saltwater grow-out. But in a traditional farm, smolts would be transferred to ocean net pens at this point. Inside the bluehouse, they move to the next tank zone, a higher salinity environment engineered within the same building. The grow-out phase is the longest. Atlantic salmon require roughly 24 to 30 months from hatching to harvest weight. In a RAS environment, that window can be compressed. Controlled temperature eliminates winter slowdowns. Feed efficiency is maximized year-round. Stocking density is monitored constantly. Too many fish per cubic meter increases stress, disease vulnerability, and feed competition. Too few reduces economic efficiency. The facility operates within a calibrated density band. Enough fish to justify the infrastructure, few enough to maintain biological performance. Biosecurity is not a protocol. It is an architecture. Visitors must change footwear and pass through disinfectant foot baths before entering any tank zone. External clothing stays outside. The fish never contact the outside world. That isolation is an operational advantage. Veterinary oversight is scheduled, not reactive. A fish health specialist reviews tank populations weekly. Mortality rates are logged per tank. Any deviation from baseline triggers an immediate diagnostic protocol. Treatments, when required, are documented in federal compliance records. Energy is the dominant operational cost. RAS facilities pump, filter, aerate, and heat water continuously. Atlantic Sapphire's Florida site draws power at industrial scale. The facility has pursued on-site solar capacity and efficiency upgrades. But the baseline energy demand does not change. Water in motion requires energy. Groundwater is the primary water source at the Florida facility. Florida's geology provides access to freshwater aquifers at manageable depths. The water is drawn, treated, and introduced into the RAS loop. Say used water is discharged through permitted treatment systems before reaching any external waterway. As salmon approach harvest weight, typically 4 to 5 kilograms, behavior shifts. Feeding rates plateau. The fish have reached the upper growth curve. Feed efficiency diminishes past this point. Yield harvest timing is therefore not arbitrary. It is the intersection of biology and economics. Harvest begins with feed withdrawal. 48 hours before slaughter, feeding stops. This allows the digestive tract to clear, which improves fillet quality and extends shelf life. The fish continue to swim in normal circulation during this holding period. The harvest corridor is a separate zone from production. Fish are crowded to one end of the tank using a movable panel, then pumped through a transfer pipe into a crowding tank adjacent to the processing area. Water carries them. No nets are used in this phase. Stunning is performed electrically. The fish pass through a water-based electrical field that renders them immediately insensible. This step is both a regulatory requirement and an operational standard. It precedes bleeding, which must begin within seconds of stunning to ensure quality. Bleeding occurs in ice slurry tanks. The fish are bled for several minutes while submerged. This removes blood from the muscle tissue, preventing oxidation and improving the color and flavor of the finished fillet. The water turns red. It is drained and treated. After bleeding, fish are moved to the heading and gutting line. This is a high-volume mechanical process. Automated machines remove heads and viscera at rates of several hundred fish per hour. Workers inspect output and remove any fish that require manual intervention. The viscera stream is not discarded. It enters a byproduct processing line. Fish oil, fish meal, and protein hydrolysate can be recovered from this material. These byproducts are sold into pet food, agricultural, and industrial markets. Nothing along the production line exits as pure waste. Dressed fish, headed, gutted, bled, are transferred to a chilled water rinse system. Water temperature in this phase is held below 2 degrees Celsius. This slows bacterial proliferation and locks in the cold chain from the moment slaughter ends. Filleting is the next stage. In higher volume operations, filleting is performed by automated machines guided by X-ray scanning. The scanner maps the bone structure of each fish in real time, and the blade path adjusts to maximize yield and minimize bone retention. Pin bones are removed downstream by hand or by automated pin bone pullers, depending on fillet grade and customer specification. Premium fillets are pin bone free. Each is inspected under a light table for remaining bones, skin integrity, and color uniformity. Color grading is a formal step. Salmon flesh color is measured against a standardized color fan scale, the Salmon fan, developed for the aquaculture industry. A score of 22 to 28 is considered market standard. Color is influenced by the carotenoid content of the feed formulation. Fillets move to a portioning line. Each fillet is weighed, and a water jet or bandsaw cutting system portions it to specification, typically 140 grams, i.e. 200 grams, or by whole fillet for retail packs. Portioning is automatic and weight verified per piece. Packaging lines run in parallel with portioning. Skin-on fillets are placed presentation side down on form trays. Modified atmosphere packaging, a blend of carbon dioxide and nitrogen, replaces the oxygen in the sealed tray. This extends refrigerated shelf life to 14 days without preservatives. A label is applied to every sealed tray. The label carries the harvest date, best by date, lot number, weight, and origin designation. Federal traceability requirements mandate that any finished product can be traced back to a specific tank, a specific harvest date, and a specific feedlot. Packed trays are transferred to a cold room at 0 to 2 degrees Celsius. The cold room is organized by lot number and destination. Trays are stacked in insulated cartons. Cartons are banded and palletized. Every pallet carries a unique scan code that enters the distribution tracking system. Outbound logistics begins with carrier coordination. Refrigerated trucks arrive at the dock at scheduled windows, not on demand. Temperature loggers are placed inside every trailer before loading. The trailer must reach 2 degrees Celsius before product is loaded. This is verified before departure. Primary distribution routes connect the Florida facility to retail distribution centers in Miami, Atlanta, and the Northeast Corridor. Same-day delivery to Southeast markets is achievable. Overnight air freight handles West Coast and export accounts. Ground transport handles volume. Air handles speed-sensitive accounts. Air freight shipments are packed to IATA perishable cargo standards. Product temperature at time of handoff must be documented. The airline cargo handler takes ownership of the cold chain record at that point. In-transit time on overnight domestic flights averages 4 to 5 hours. At the retail distribution center, pallets are received, scanned, and transferred to refrigerated holding. The salmon enters the store's cold chain management system. Orders to individual store locations are picked the following day and loaded onto regional delivery trucks before dawn. The store receives the product the same day or the next morning, depending on route. Seafood department staff break down the cartons, verify temperatures, and place product into the case. The label the consumer reads in the store is the same label applied at the processing facility 2 days prior. The competitive position of land-based salmon is built on consistency. Ocean salmon farms are subject to sea lice, algae blooms, storm damage, and temperature variance. RAS Farm is not. That reliability carries a price premium with buyers who run high-volume, consistent programs. The main expansion project represents the next phase of the bluehouse model. The site is larger. The tank volume is greater, and the proximity to the Northeast seafood market shortens logistics time. When complete, the combined output of both sites is projected to exceed 10,000 metric tons annually. The capital intensity of RAS facilities is significant. Constructing and equipping a full-scale land-based salmon farm requires investment measured in hundreds of millions of dollars. Infrastructure costs include concrete tank construction, water treatment systems, mechanical and electrical installation, and processing facility build-out. The regulatory environment for land-based aquaculture differs from offshore operations. RAS farms fall under state environmental permitting for water discharge, federal food safety oversight under the FDA and USDA National Organic Program rules if organic certification is sought. Inspections are unannounced. Sustainability claims in land-based salmon production center on several metrics. No bycatch, no sea lice chemicals, no ocean cage waste discharge, and the ability to site facilities near consumption markets. These are operational facts. Their relative significance is assessed differently by different buyers. The workforce inside a RAS facility spans multiple disciplines: water quality technicians, mechanical engineers, feed specialists, fish health veterinarians, harvest crew, processing line workers, quality assurance staff, and logistics coordinators all operate under the same roof. Shifts run 24 hours. Production does not stop. The central control room monitors all critical systems from a single location. Tank temperatures, oxygen levels, feed delivery rates, water flow, alarm states, all are visible on wall-mounted display panels. A duty technician reviews alerts on rotation through each shift. A single alert can initiate a full tank inspection within minutes. The morning shift change at 6 a.m. This is a structured handover. Outgoing technicians brief incoming staff on any parameter deviations, mechanical issues, or fish behavior anomalies observed during the previous 12 hours. Nothing is assumed. Everything is logged. The incoming shift begins with a full tank walkthrough. One harvest batch represents months of accumulated operational input. Feed costs, energy costs, labor costs, water treatment costs, they are all embedded in the price per kilogram leaving the dock. The margin is thin. The volume is what sustains the model. The truck pulls away from the dock. The loading bay door closes. Inside the facility, the tanks continue their cycle. New fish are growing in the stages vacated by the harvest batch. The system resets without ceremony. The next cohort is already on schedule. The water inside the bluehouse keeps moving. It is filtered, re-oxygenated, and returned. The tanks receive the next feeding cycle. Somewhere on a highway, the product from this morning's harvest is already in transit. But the system does not pause between batches. Under this video, there's a subscribe button. It's a small action, but it helps document how water becomes food at scale. If you're curious about the systems behind seafood production, consider subscribing. And tell us, where are you watching from? Have you ever worked in aquaculture or seafood processing?